We have seen the previous concept of scenario planning with simulation models. And now let's talk about another fascinating and highly engaging technology known as AR and VR, or augmented reality and virtual reality. Imagine a warehouse manager at a global retail company like Walmart trying to train new staff quickly, or visualize storage layouts without disrupting actual operations. AR and VR make such scenarios possible by blending digital information with real-world environments or creating entirely virtual worlds for immersive experiences. Augmented reality, or AR, adds digital information to the real world. Imagine wearing AR glasses in a warehouse. Arrows could appear on the floor showing the fastest route to pick items, or product details could pop up when you scan a box. It's like adding smart layers to what you already see. Virtual reality, or VR, is different because it takes you into a fully digital world. For example, supply chain managers can use VR headsets to walk through a virtual factory design before it's even built, spotting issues and improving layouts. So Arkansas enhances reality with useful data, while VR creates a new digital environment for training, planning, or design. These technologies have been evolving since the 1960s, with major adoption in industrial applications accelerating over the last decade due to improvements in sensors, computing power, and head-mounted displays. Let's understand how this technology works step by step. Our first type is augmented reality, where devices like smart glasses or AR-enabled tablets project digital labels, instructions, or navigation cues onto real objects. For example, a warehouse worker can see optimized picking paths highlighted on the floor while collecting products. The next type is virtual reality, where headsets immerse users in a digital twin of a warehouse or manufacturing plant, allowing them to practice complex processes, plan layouts, or run safety drills without any risk. Step by step, the worker wears the device, interacts with virtual or augmented elements, receives real-time feedback, and improves efficiency or learning outcomes. The uses of AR and VR in supply chain and operations are numerous. One use is in warehouse training, where employees can learn picking, packing, and safety protocols in a virtual environment, reducing training time and errors. Another use is in maintenance and remote assistance, where technicians wear AR glasses to get live guidance or overlay schematics while repairing equipment. A third use is in supply chain planning, where managers visualize facility layouts, test storage strategies, or simulate workflows before actual implementation. A top real-life case study is DHL, which faced challenges in training warehouse staff efficiently across multiple global locations. In 2017, DHL implemented AR glasses in select warehouses, allowing workers to see picking instructions and optimized paths directly in their line of sight. As a result, they reported a 15% increase in picking efficiency, reduced training time by 25%, and fewer errors, demonstrating the tangible benefits of AR in operational environments. VR has also been used by DHL for management to simulate complex scenarios and improve layout designs before physical changes, saving time and cost. So, in a nutshell, we simply seen that AR and VR provide immersive, interactive, and risk-free ways to improve learning, efficiency, and decision-making in supply chains and manufacturing. Hopefully, you like this concept because it illustrates how blending the digital and physical worlds can revolutionize operations. That's amazing learning I believe you have today, and a perfect example of how technology is making supply chain processes smarter, faster, and more engaging.